Good evening, everyone. My name is Nick, and I'd like to welcome you back to another Tech Talk in our series sponsored by Pressable. Today, we have the pleasure of welcoming Elizabeth Vidal, who will be giving us a brief talk on message brokers. So without further ado, I'd like to pass it over to you, Elizabeth.
Thanks, Nick. Before we begin, I'd like to thank Pressable for sponsoring this Tech Talk. So let's talk message brokers. Today, we'll be going over what message brokers are, some common use cases, how they work in your overall architecture. We'll quickly introduce KubeMQ, go over some other message brokers, and then review it all. Since we've got a lot to cover, let's get to it. So what are message brokers? Message brokers are software that enables services and applications to communicate with each other using messages. Because the message structure is formally defined and independent of the services that send them, applications can share information with one another, even if they're written in different programming languages. So message brokers can work in a few different ways, but there are two major methods: the producer-consumer and the publisher-subscriber, otherwise frequently known as pub-sub methods. So the first method is the producer-consumer. In this method, the producer sends messages to the message broker. The consumer consumes the messages waiting in the message broker. Here, the message app broker acts as a queue. If you're familiar with data structures, you know that a queue works in a first in, first out method. It can support both synchronous and asynchronous communication patterns. This method is most often used for one-to-one relations between the sender and the receiver. And if that's the case, you might be asking, why not use a REST API? Well, unlike a REST API, the message broker ensures that the message makes it to the consumer, even in the event of disconnection. It's stored in the queue until it's sent. Method 2 is the publisher-subscriber method. In this method, the publisher doesn't know about their specific recipients, but instead sends messages to queues that have specific topics attached to them. These topics, as they're referred to, are the logical channels that messages are published to. Once the messages are in their topics, the subscribed endpoints receive the messages. This would be considered a one-to-many relationship because many subscribers can be subscribed to one topic. So I know this sounds amazing, but it can be kind of hard to visualize when you'd use a message broker. So let's talk about some use cases where a message broker would be useful. First, let's consider a fighting game. In real time, multiplayer fighting games, latency, or the time it takes for data to pass from one point on a network to another, is critical. Message brokers can help by managing the timing and delivery of game actions efficiently. For example, when the player wants to fight, the game will send a request to, let's call it the matchmaking service, which finds another player to fight the requester. Then it publishes a match-made message to the matchmaking queue. When the players are matched, the game server, which is subscribed to the matchmaking queue, receives the player's information and sets up the fight. Then it sends a message to the players starting the match. Pretty cool, right? But message brokers can even be used during the fight. Each player's actions are sent to the game server, and the game server publishes the actions to something called like a game actions topic, and both players' clients subscribe to this topic. This way, they receive their opponent's actions and update the game state in real time. Game state management, match results and leaderboard, and chat can all be managed by a message broker. So let's talk about the other side of the spectrum and talk about banks. Message brokers can help banks communicate with their customers by managing different types of notifications and ensuring that messages are sent according to the user's preferences. Banks often send out texts, notifications, and emails for various events like transaction alerts, low balance warnings, or suspicious login attempts. For example, whenever a transaction happened, the bank system generates a transaction event. The event publishes to a transaction events queue in the message broker. Then a notification service, which is subscribed to the transaction events queue, receives the event and checks the customer's preferences, either SMS, email, app notification, or if they're even opted in. Finally, the service creates a message containing the transaction details and sends it to the customer. So now that we have a deeper understanding of message brokers, you're probably wondering how that would even fit in your system design. Let's pretend you made your amazing Matching Jewels app and you've containerized it in Docker. As a reminder, we containerize apps to prevent the "it works on my computer" issues. Docker creates a neat package of your app with its dependencies, so it's fully contained and can run anywhere. Think of Docker as a violinist who can play your app anywhere they go because they've got the sheet music dependencies. Okay, so you've built your container, but you realize you actually need to scale up way more than you expected. You just need you just need way more than one container image to meet the demand of your app. This is where something like Kubernetes comes in. Kubernetes is a system that manages containers and takes care of deploying, scaling, and operating multiple containers across a cluster of machines or services. Kubernetes makes sure your apps runs reliably and can increase or decrease containers based on your demand. It's like if your app required a bunch of violinists because you're playing in Carnegie Hall. Consider Kubernetes your orchestra maestro, coordinating all the violinists to play in harmony. These containers, or violinists, are all in their own little containers that Kubernetes handles in a cluster. But as your app grows, it isn't just about running more containers. Now you're getting flooded with API requests, and this increase in traffic is creating latency issues, affecting both performance and scalability. So how do we handle that? I'm pretty sure my leading question is obvious. So let's talk about a message broker that's made just for Kubernetes. Remembering your app, the message broker will act as an intermediary that manages and distributes the requests efficiently, ensuring that your app can scale further without being overwhelmed with the flood of incoming data. Message brokers keep everything flowing smoothly, like the logistics team behind a major event, ensuring that the right messages get to the right places at the right time. So I'm sure by now you've heard of Apache Kafka and RabbitMQ, and possibly even some of the AWS message broker services that are available. So I want to focus on KubeMQ. KubeMQ is an open source message broker made specifically to work with Kubernetes. KubeMQ was created around 2018, so it's relatively new. As I mentioned before, Kubernetes manages containerized applications, and KubeMQ is designed to work efficiently within Kubernetes environments. KubeMQ has the producer, consumer, and pub sub services that many message brokers have. It also provides streams, which is handy if you need real-time data streaming between services. KubeMQ also auto-scales based on your container demands in Kubernetes, makes sure that your new instances of a service come online as needed, and that way they can start immediately sending and receiving messages. And KubeMQ handles the health of services and can restart them if they fail. Even if a service is down, the messages are not lost and can be processed once the service is back up. Something like KubeMQ overall makes your system even more scalable and easier to maintain. Now, I know this sounds like an ad for KubeMQ, but here are some reasons to consider using it over other message brokers if your app utilizes something like Kubernetes. For one, it's in the name. KubeMQ is literally designed to work with Kubernetes, and it takes advantage of existing Kubernetes features like auto-scaling, service discovery, and self-healing. It's easy to deploy and manage within a Kubernetes cluster. And because KubeMQ supports many messaging patterns such as PubSub, queues, streams, etc., it's flexible in allowing the developer to choose the right pattern for their use case. That being said, there are definitely many reasons why you may not want to use KubeMQ. As I mentioned, KubeMQ is a fairly new software, and as such, it has a much smaller community than more established brokers like Apache Kafka or RabbitMQ. That means that resources are less available to help developers navigate the steep learning curve. And because of that, despite the fact that KubeMQ can simplify a lot of aspects of message brokering, it is a whole other software you have to learn on top of Docker and Kubernetes with not a whole lot of support. There is literally like one Reddit thread on KubeMQ. So this is another layer of complexity to your system. KubeMQ also requires additional resources within your Kubernetes cluster, which includes CPU, memory, and storage, and that can increase your operational costs. Also, using KubeMQ just because you're using Kubernetes might trap you in a vendor lock-in, making it harder to switch to a different message broker that might meet your needs better. Finally, unlike Kafka and RabbitMQ, KubeMQ does come with a cost. There's a community version that's free, but it's not helpful for apps in the production stage. So the big question, how do you choose between message brokers? As the Bard of Avon doubtlessly said, I don't know. There are quite a few message brokers out there. Redis Streams is a lightweight asynchronous message broker. Apache Kafka is open source and helpful if your app has uncomplicated routing with a lot of data. RabbitMQ is also open source and ideal for integrating multiple apps and services that need a rapid requested response. AWS also has a couple of managed services, such as Amazon Simple Queue Service or Amazon Simple Notification Service. Whew, okay, so we've made it to the review. So to recap, a message broker is a software that enables communication between applications or services via messages. It's especially beneficial for large-scale apps where you need to handle a high volume of messages and ensure reliable and scalable communication. All that is to say, for a simple application, it might just be better to use a REST API. When using a message broker, it's good to consider the overall pros and cons. So message brokers can provide communication between services that aren't running at the same time and send messages whether or not the consumer or the producer is active. Tasks that take a lot of resources can be distributed into separate processes, which can make your application faster overall. And message brokers usually have a redelivery mechanism. So in the event of send failure, the broker will redeliver the message. This is way more reliable for making sure that your consumers receive their messages. That said, it can be really complicated to implement a message broker. Once implemented, you have to worry about maintaining the network between the components, security issues, and that some components may not have up-to-date data until all the messages are processed. This can lead to some issues with consistency. To combat that, if your app is in production, consider using a managed message broker like AWS SQS, Azure Service Bus, or KubeMQ Cloud. They abstract away a lot of the complexity when it comes to setup, maintenance, scaling, and security. If a managed service isn't an option, there are still lots of ways you can maintain data integrity, eventual consistency, and ensure secure connection. As another con, debugging is way harder because you're working asynchronously. A single message goes through multiple stages of processing, and each service it goes through will have its own logs. A way to solve this would be to add message tracing when implementing a message broker. It can trace the path of the message and ensure that messages are delivered as expected. It can also provide real-time data on the state of messages. Apache Kafka, RabbitMQ, and KubeMQ all offer this service. Finally, there is a steep learning curve. I hope I've made message brokers sound easy, but actually implementing them requires a lot of setup and configuration. It's why if you don't have the volume to justify a message broker, a REST API may be the better option. But if you feel your app would benefit from a message broker, then I suggest embracing the hard learning. Apache Kafka, RabbitMQ, and Kube Community are all open source and free to use. At the production stage, you may need to consider a managed service, but while you're in development, why not struggle a bit? So you survived. We all survived. Life is beautiful. This is my works cited page. This is my other works cited page if you'd like to learn more about message brokers. Or you can contact me on my LinkedIn or follow me on GitHub, and we can grab some coffee and talk message brokers. And once again, I'd like to thank Pressable for sponsoring this Tech Talk. Thank you.
Wow, Elizabeth, that was awesome. That was a very, very thorough coverage of a lot of the topics. You also need the prerequisite information that you need to understand. That was fantastic. We have time for one question if anybody would like to ask Elizabeth a question tonight.
Oh,
yes, Edwin?
Elizabeth, is there a particular place that you think is a good starting point to kind of learn about all these technologies? I know you covered so much, everything from pub subs to like Kubernetes, to message brokers, but like, where would you recommend kind of like learning as much as you seem to learn about all this information?
That's a great question. Thanks, Edwin. So I would say definitely the first place to start would be learning Docker. Docker is super important for containerization. Kubernetes is a service that manages containers. And so before you even go into Kubernetes, you have to understand how Docker works. Then you can move into Kubernetes. And again, Kubernetes just happens to be a popular one and happens to be the one I focused on because KubeMQ is a new technology and I wanted to explore it. But there are other container orchestrators besides Kubernetes that you can also explore. So if you're really interested in learning about message brokers, though, I would suggest starting with Apache Kafka or with RabbitMQ because they have a larger community. There's a lot more information out there, and they've got really robust docs that can help you with learning how to use a message broker.
Thank you so much. That was an excellent answer, Elizabeth. I really appreciate it.
That
You're
was
welcome.
fantastic. Elizabeth, thank you very much for that talk tonight, and thank you everyone for coming out. We'll see you at the next one.